So welcome to the 7th virtual office hours for the 2014 POSA MOOC. Today we're going to talk about a couple different topics. We're going to first go over my solution, or rather our solution, to week 6 assignment number 5. And then we're going to answer any questions that we have about week 6 assignment 5. And after we're done with that, then Jules White is here, and he will talk about the upcoming assignment, which is week 7, assignment number 6. And I'll also go over a couple other interesting things. I want to show the Acronym application that I released recently and kind of walk through its design. That may help people with some of the programming for week 8, assignment number 7. So with that, why don't we go ahead and get started? I will bring up my editor and I will walk through the solutions. Let's see, first got to find Emacs, find the Emacs window, somewhere around here, lurking. There it is. All right. Hopefully you can see this. Let me just double check to make sure the window's up. Yes, the window is up. And so let's go ahead and start talking first about the week 6 assignment 5 solution. So you can see here, this particular solution had 5 files in it. 3 of the files were files that you were going to make some changes to, and there were 2 other files that were there just sort of to help you with providing some of the implementation and providing some of the boilerplate code that we needed to have to display the images and get the input from the user and so on and so forth. For people who were bored with the help that we provided, of course you can always just ignore download utils at first and try to implement the whole thing yourself, just using the overall skeletal parts of it, and that might give you a bit more understanding of how things work, and then later you could come back once you understood how to implement it yourself and then retrofit your solution into the overall framework that we provided here. We provide the skeletons, of course, because not everybody has all the background necessary to make sense out of all this stuff. Okay, so let's start by taking a look first at the client side. This is the download activity. As you can see, there are a lot of comments in here. This solution was done by Mitchell Gordon, who's one of the students working with us this summer, and he did a real nice job of not just providing the skeleton of the solution, but also commenting heavily what patterns were being used. So as you can see here, we have download activity, and download activity extends download base. And we'll take a look at that. This is a little pattern I've used for most of the assignments and most of my examples lately, where I try to separate out the user interface portions of the code from the communication portions of the code. There's no particular motive to do this in real applications. I just found it was easier for explaining this if I could separate them out a little bit. So let's just take a quick look at download base to see what it does. This is what has the various widgets, the edit text window, and the image view window, and the bitmaps, both the default and the current bitmap, which we use to help with some of the testing. We have a method called display bitmap, which is assumed to be running in the user interface thread, of course, and it uses the bitmap factory decode file method in order to be able to take the path name and decode it, turn it into a bitmap, and then go ahead and display the bitmap on the image in the image view. So that's pretty straightforward. Get URL string is just a little helper method that gets the URL that was provided by the user. We have a method to reset the image so that you can go back to the default. And then we have the onCreate hook method, which is basically a virtual constructor that's used to initialize the activity. It basically sets up all the GUI widgets and controls and the view and so on. So that's basically what download base is. Nothing particularly interesting or surprising there. Download activity is a little bit more interesting, at least for the purposes of this class, because this is what actually does the communications portion. As you can see here, it extends download base, and then it also defines a static nested class called message handler, which extends handler. And we use a weak reference here for reasons we've talked about in previous classes. If you go and look at this link here, you'll see more explanation about why we do this to avoid circular dependencies that would make garbage collection difficult. The constructor, as you can see, just goes ahead and stashes away the download activity reference as a weak reference. And then the main method here is one called handle message. Handle message is going to be used to get the result from the service sent back to the activity. And as you can see here, it goes ahead and grabs the activity, assuming the activity exists and it hasn't been garbage collected. Then we're going to go ahead and take the information that's passed in the message. As you can see here, the message comes in as a parameter to handle message. And we're going to take this data and we're going to go ahead and extract the data portion of the message, which is a bundle, and we're going to get the path name from this, and then we're going to go ahead and display that as a string. This is how I did things in the original shells. I came up with a better solution, which I didn't put out on the website, so people, of course, are not obliged to do it, but I just did it because it seemed cleaner. I wrote a little method that I put into download utils later called getPathName, and that kind of cleans things up and it encapsulates the client from any knowledge of how these data structures are stored. The messages are stored internally, so it just makes things a little bit less coupled, a little bit less implementation oriented. But of course, this is perfectly fine for the solution. So as you can see, it just displays this. Keep in mind that handle message will get called back in the user interface thread. So it can't block for long, and it doesn't. It just calls display bitmap. Here is an instance of message handler. As you can see, this is defined in the member variable definition portion of download activity, which means it's going to be running in the main thread of control because it's a handler, and the handler will be registered in the thread where it's created using thread-specific storage pattern. And it takes this, which is the activity, and passes that in as the reference that it holds internally. Here's the method that gets called back when a user clicks on a button. It calls the run service method, and then that goes ahead and figures out which button was clicked. You can either click the intent service button or the thread pull button. In either case, we do essentially the same thing. We go ahead and we use the appropriate factory method, make intent, which is defined on the download intent service class, or make intent, which is defined in the thread pool download service class. In either case, we go ahead and make an intent. We'll look at that implementation shortly. And what we get back is an intent, of course, with the various fields set up properly. And then we go ahead and call start service, and that will then launch the service that corresponds to the service that we're indicating here, thread pool download service or download intent service. It'll launch that service and pass the intent containing all the other information over to the service. And we'll look at that code in just a second. And then when we're done, we pop up a text, a toast rather, that says that we're basically starting to download. Okay, so that's basically it so far. So let's go take a look now at the service implementations. Let's start with download intent service. Download intent service is an intent service. If you watch the video on the Android intent service, of course, you know that an intent service is an implementation of the command processor pattern, which is described in the Gang of Four, or sorry, in the the POSA 1 book, and the POSA 4 book has information on the command processor pattern. And basically what that pattern does is it lets you send commands which then get executed in a different context. In this particular case, that context will be a separate process and a separate thread in a separate process. Here is the constructor, which just calls up to the superclass, needs to do that in order to initialize things properly, give it a name, and so on. And over here we can see the make intent factory method, which is in the service, just because that way we encapsulate all implementation details in the service. The service really needs to know how to start itself. It really needs to know what information needs to go into it so that it can have the information at its disposal when it gets the request from the client via start service. And this goes ahead and just delegates down to the download utils make messenger intent. We'll look at that more in a second, just passing some of the parameters in. Here's the only other method in this implementation. This is the on handle intent method. If you watch the video, you know that on handle intent gets called in its own thread of control. There's one background thread per intent service, and when a request shows up, then the onHandle intent hook method gets called back in that thread. Under the hood, of course, it uses the command processor pattern, and it uses the Hammer framework and other things to do this processing between threads. And all we do here is we just simply turn around and say, download utils, download and respond. And we give it the data, and we give it the messenger, and those two things are passed in. I later came along and came up with a better implementation that's a little cleaner. I'll show you that when we get to it, where I just pass the intent in here, and that again hides more of the implementation details from the bulk of the code. So you can see this is basically just sort of a one-liner. It's not a whole lot going on there. Let's go take a look at the, oh, and the other thing is, remember, an intent service shuts itself down automatically when there are no more clients to process. We don't have to do that ourselves. That's handled for you by the intent service. And if you watch the video, of course, you'll learn how that works. Here is the thread pool download service implementation. Unlike the download intent service, which inherits from intent service, the thread pool download service is a service, which means it doesn't shut itself down automatically. In fact, for the purpose of this example, that's exactly the point. We don't want to have it shut itself down. We want to have it running in the background, handling requests, so it doesn't start itself and shut itself down on every request. To do this, we're going to create a thread pool using the executor service. We're going to have 4 threads in the pool. In the onCreate method, which is created when the service is first started or first launched, you can see we go ahead and make ourselves an executor that's a fixed thread pool executor with 4 threads in it. Very simple to do using this factory method that does that. Here's the make intent method. The make intent method is called to make an intent, and you can see that's pretty straightforward. Does pretty much the same thing that the other one, that the make intent method for the download intent service did, except it passes in the thread pool download service class instead of the download intent service class. Here's the onStart command method. The onStart command method is called whenever the start service method is invoked. So start service, when it's called the first time, will use the activator pattern to launch the service, and henceforth every time it's called it's already running, unless it shuts itself down, of course. And this passes in the intent that was sent along with start service, along with some other information as well, which we pretty much ignore in this implementation. What we do here is we create a new runnable, which we call download runnable. As you can see, this runnable basically is going to be given to the thread pool executor to run in a separate thread in the thread pool. And when this gets run, its run hook method turns around and calls download and respond, basically doing the identical thing that we did in the download intent service, except now this is being called in a thread and a pool of threads, but it's the same basic idea. So that's what it does. And here's the onDestroy method. As you can see, onDestroy, when this gets called back, we'll go ahead and shut down the executor. And onBind is just something we have to define if we're making a service that's not a bound service. We just have to have it return null, and that's an indication this is not a bound service. Okay, so that's the thread pool download service. Those were the things that you needed to fill in. Let's take a look at the download utils class, which is where all really the brains of this stuff go. Here's the make and messenger intent method. Keep in mind this is called by a couple different things. It's called by the download intent service, and it's also called by the thread pool download service. And as you can see, what it does is it passes the service in as a generic parameter, so we can pass in either one. We then make a new messenger with the handler that's encapsulated here. We make a new intent with the activities context and the service class, and then we go ahead and we put the messenger we created into the intent as an extra, and we go ahead and use the messenger key to put it in under that name, and then we go ahead and set the data to be the path name, or rather the URL, the URI that was given by the caller. Now, people ask some questions. What's the difference between put extra and set data? They can often be used interchangeably. The main reason for using set data is because the data that's put into an intent can be filtered upon. And we typically do things like put URLs in there, and then we could use the intent filter framework, the intents framework that Android defines, in order to be able to filter out certain kinds of URLs and have them handled in certain kinds of ways. So, for example, the Maps application does this. It looks for things that have map operations, and it treats them specially. And so that's why set data is typically used for URLs, because this data can be filtered upon. Whereas messengers, as far as I know, or sorry, not messengers, as extras, as far as I know, are not filterable. So basically, that's what we do. This is a factory method, and as you can see, it encapsulates all the implementation details for creating an intent that has all the various fields, extras, and data set up correctly. Now, the other thing to notice, and this is kind of funky at first, this call, when it's invoked, always runs in the context of the activity. Even though it's defined in the service, it's run in the context of the activity. There's no call crossing process address spaces or thread address spaces here. This is just shielding the activity from implementation details it shouldn't have to know about. So that's why that goes there. Here's the send path method. We'll see how this gets used in a second. Let me first show how that's used, and then we'll come back. Here's the download and respond method. Download and respond is what's called by either the on-handle intent method in the download intent service, or it's called in the run method in the thread pool download service. And what this guy does, as you can see, is he downloads the file at the URI. We'll look at that in a second. And that's going to give back a path name. And then he takes that path name and he calls send path with the messenger. And over here, if you look at send path, it goes ahead and it makes a new message. It creates a new bundle. It sticks the path name as a string into that bundle. It then makes that bundle the data for the message, and then it goes ahead and it sends that message back to the client activity using the messenger. Keep in mind that this particular call, in both examples we're looking at here, runs in a separate thread of control, either in the single background thread in the intent service, or as a thread in the pool of threads in the case of the thread pool download service. So that's what send path does. Then we had a couple of different ways to download files. We wanted to make life easy for people who didn't have a good network connection. So by default, we set things up so it stores everything and just returns basically a file that was located on the file system in the resources that were part of the application. Obviously, in real life, you wouldn't do this because that would be pretty pointless. But that just basically does that. Otherwise, if you actually were going out and going across the network, then we went ahead and called this helper method called get temporary file, and we'll look at that in a second. And that gets us a temporary file, and then we use the URI to go ahead and download the content of the file, and then we copy the content coming in from the input stream that corresponds to the downloaded content from the web server, and we copy that into the temporary file, and when we're done, we return the absolute path name of the temporary file. Now, for testing purposes, and this was just to make your life easier, this is not what I would ever do in real life, we always put the file in a place that corresponded to the URL that you downloaded. So we just used its name and made a file with that name. And that allowed us to be able to not fill up your file system with temporary files that were all unique. Obviously, you would not do that in real life. You would do this or something like this. Here's an example where we create a temporary file that has the current time in milliseconds that's used to give it a name that will hopefully be more unique. And there are probably other ways to make temporary files that you could also use as well. Here's the copy algorithm. As you can see, it's very simple. It just takes the input and the output stream as parameters, and it goes ahead and it reads from the input stream and it writes the output stream, and when it's all done, it returns the number of bytes that it read. So that's pretty simple. Okay, so that is basically that solution, and as you can see, it's pretty simple, but it's kind of cool, and it illustrates how you can use messengers to communicate results from started services back to activities that start them. And if you watch videos, there's a bunch of other videos that talk about other ways to communicate and talk more about how this particular approach works. Okay, so there's a question, first question from Jet asks about contexts. So this is one of the truly mysterious aspects of Android. If you take a look on the discussion forum, there were a couple good links to Stack Overflow articles that go into more detail. The general rule of thumb that I find is use the context that makes the most sense for what you're trying to do in the most limiting way. So if you're trying to create something that is associated with a service, use the services context. If you're trying to create something that's associated with an activity, use the activities context. You can almost always use the application context, but according to the reading I've done, that's usually the wrong thing to do, because you end up having dependencies on your application. That means that the application has to hang around a lot longer than it might otherwise have to do. In particular, when you're defining services, as we're doing here, you often want those services to be able to run in the background and not necessarily be tightly coupled with a particular application. They're supposed to be independent of the application, something like a daemon process that you would have in Unix, for example. And so in that case, you probably want to use the services context. But I recommend you take a look at Stack Overflow and look at the discussion forums. There's lots of discussions, lots of good pointers to people from Google use this stuff. This is not very well explained, though, in the documentation, so I can see why people are confused about it. There was a question, can you use get parcelable extra instead of using get extra? Yeah, sure, you can do that. In fact, I think I have another solution to this program that I wrote, and rather than confuse people by showing it, I won't show it. But as I learned from feedback I got, I revised a few things, and that's one of the things I used. I ended up using get parcelable extra, which is just a little bit of a shorthand, which is fine. Let's see. What do you mean in the course for week 8 when you say AIDL is easier to implement bidirectional communication between two processes? So one of the nice things about AIDL, as opposed to using, well, I think what I really said was the following. Bound services are used to allow you to do bidirectional communication. So with a bound service, you set up a conversation channel that can allow the client, which is typically an activity but doesn't have to be, to invoke methods on an object that resides in the service. And when the service, that object is done, it can then give a result back to the client. And we'll talk in a bit about how AIDL makes that easy. Messengers make that easy too, of course. So the main thing there is that bound services make it easy to have two-way communication. As you saw with the started service example that we had here, we had to kind of do some additional stuff in order to make two-way communication work. We had to pass a messenger with the intent, and then we had to be able to take that intent, fish out the messenger, and make a call back. So it certainly is possible to have two-way communication with an activity and a started service, but it's just more awkward. And it's, you have to do extra work in order to get the replies to work, for example. Whereas with a bound service, especially a bound service that uses AIDL, it's really easy to get the result back to the client because you've either used the two-way method, in which case the return value can give you back the results, or any out parameters can get you back any results. Or if you use the asynchronous callback model, which we'll look at in a second, then you have a callback object that was passed to the original service, and then it can use that to communicate back. So two-way communication, especially two-way communication that takes place over a long period of time, where you're making requests and getting responses in a client-server-like way, is way, way easier with bound services, and especially with AIDL, than it is with anything else. And that's what that means. Can you summarize which methods are in the service and which are in the GUI? So let's see. So, well, it's usually pretty easy to tell just by looking at the code, but I'll walk this. For example, run service, it starts the service. Yes, that's correct. And it includes make intent method. That's also correct. It has to know what service it's going to talk to, so it uses make intent in order to get back an intent from the factory method that's defined in the service. I visualize an intent as a messenger, not actually part of the service. It's possible, Del, to visualize an intent as a messenger, although that's probably not quite the right phrase because there's something else called a messenger. I think what you mean here is a message. But at least for the way that we're doing things here, where we're giving an explicit name of a service, then we have to know which service it is. And so that information has to be put somewhere. And so the way that we're doing it here, we kind of make that be a factory method that's localized. A service knows, in our implementation using the factory method pattern, a service knows how to create an intent that an activity can use in order to get it started and pass messages to it. Now, if you wanted to, if you didn't want to have that dependency on the service, then you could use something like the download utils class, which is sort of an intermediary, and you could put all the stuff that had to do with communication there. And in that particular model, then the activity could say download utils, make intent, or make messenger intent, or whatever you want to call it. But it really shouldn't necessarily be the activity's job to know all the implementation details of how communication is implemented. It really kind of should be localized somewhere. So in this particular example, I kind of put it in the service, but you could put it other places too. You could put it entirely into the download utils class. So Ashley asked the question, one of the students called download utils make messenger intent from download activity. Yeah, that's fine. I mean, that's actually what we were just talking about. If you don't want to have a dependency on the service, then you could call download utils. The key point is to abstract away these implementation details so they don't litter the code, and you only have to go to one place in order to be able to do updates and modifications. All right. Why doesn't the thread pool stop itself? Well, that's the whole point of a thread pool. What would be the point of having a thread pool that stopped itself after one request came in? That would defeat the whole point of having a thread pool. The idea of having a thread pool is to amortize the startup time for creating threads so that you can create the threads when the service starts, and then as the requests come in, the threads are already running. Now, obviously, if you have a service that's only going to be called one time, then it was completely a waste of time to spawn a pool of threads, so that would be silly. The particular download activity that we have here doesn't really exercise the thread pool in a cool way unless you sit there and just pound away on the request image button. Some people have posted other implementations of download activity that are much more interesting, that have a loop that requests a bunch of images in a loop, and then that actually does use the thread pool. Now, there's a video that occurred in the 2013 POSA MOOC where I talk about different ways of designing servers, and I differentiate between a so-called one-shot server and a standing server. And so in this particular case, the download intent service is essentially a one-shot server, although we'll talk in a second about how it can actually process multiple requests, whereas the thread pool download service is a standing service. It starts up, it runs for the lifetime of the, till it's shut down by some other entity, like a background process or something. There are lots of system services in Android that are standing services. They start when your phone boots up, and they run for the duration of the lifetime of the phone. And of course, there are trade-offs there, right, between resource consumption versus latency of starting things up and down. That's why you should take a look at the activator pattern, which will be appearing in next week's videos. If you go to my YouTube channel, you can see this week's implementation, or this week's videos, or this next week's videos are already posted. You can take a look at those. Let's see. Try to say anything else more about thread pools. Oh, I know, the intent service. So an intent service will continue to run as long as intents show up at it concurrently. Whenever it gets to the point where there are no more intents to process, then it shuts itself down. But as long as there are intents to process, which means they're coming in concurrently, the intent service will remain running. So it's kind of a variant between a one-shot server and a standing server, and it basically lives as long as there are clients requesting. What will happen with the thread pool executor if we kill the service? So it depends on what you mean by kill the service. If you shut the service down by its on destroy, if you shut the service down in a graceful way, and or the system shuts the service down in a graceful way, and its on destroy hook method is called, that will then go ahead and shut down the thread pool. And that, under the hood, I believe, uses the Java thread interrupt model, and so hopefully in the not too distant future, it'll shut itself down. And if you want to take a look at the implementation of the thread pool, executor, it's lurking in the libcore loony subdirectory in the Android release. You can take a look at libcore, which is where all the sort of the Java classes live, and you can take a look in Java util concurrent, and I think it's living in there somewhere. It's pretty cool implementation, by the way. We briefly outlined it in one of the earlier videos. If you kill the service and if you shut the process down, like the Android Reaper that comes along in the low memory killer or whatever they call this thing, that will shut the process down. And of course, when the process shuts down, then the thread goes away too, or the thread pool goes away too. So those things will not run indefinitely once they're shut down. When communicating between activity and service, could we ever use the observer pattern for two-way communication? Yes, absolutely. In fact, a not uncommon thing to do, although it has kind of fallen into ill repute in some ways, is to use some kind of broadcast receiver as follows. And I'll tell you first how it works. There's actually some videos that I might go ahead and post that show how all this stuff works if you're interested. But basically, what you do is on the activity side, you register a broadcast receiver with some tag or some information that you can use to get to it. And then when you send the request to the service, either in the request or through some other means, the service knows how to go ahead and send a broadcast back to the broadcast receiver, which runs in the client or the activity. And so in that case, that's basically using the observer pattern, or really more specifically the publisher-subscriber pattern, which is a variant of observer. And that way you can have the service responding back to the activity through a broadcast intent. The downside with that is broadcast intents are sort of falling into ill repute because they are used for various kinds of security holes, or it's ways to exploit them. And I believe that Jules might talk about. Did you talk about broadcast receivers at all?
Yes, we talked about some of that in the assignment.
So in the videos that Jules White has on Android security, there's discussions about sort of hijacking intents. In fact, what's the name? Is it activity hijacking or something like that? There's some name.
Privilege escalation. He talks about some of these things.
So privilege escalation. There's things where people can masquerade as intent receivers and then steal the intents and do bad things and stuff like that. But there are a bunch of ways to get around this. I don't really talk a lot about broadcast receivers in this MOOC, although if you take a look at my YouTube channel for the CS282 course, there's a whole bunch of videos that talk about broadcast receivers and the publisher-subscriber pattern. And depending on how things go, I might publish some of those as optional lectures later. Let's see. I had a different way to use on-handle intent than what you showed. So this particular approach gets the messenger, and yeah, Sheila, there's a bunch of different ways to implement this. I just use the download file and the download image and respond method because it just kind of does it all in one method call. But there's certainly other ways to do it, and it's fine if you do it that way. The key thing is to do it right. Can we use the scheduled thread pool? Yes, you probably could use scheduled thread pool. There's a whole variety of different thread pools that are provided by the executor service, and so take a look around and see which ones you like the best. Let's see. Derek has a question. I'm still confused about the differences in the service life cycles of started versus bound services. So in week 6, assignment 5, we don't explicitly stop the download intent service. Okay, so keep in mind, so first, Derek, go back and watch the video on Android intent service. It goes through this, what I'm about to say, in a great amount of detail. You might also want, in fact, you also should go back and watch the videos entitled Programming Started Services. There's a pair of them. They walk through the protocol for shutting down a service in great detail. So the bottom line is a started service will continue to run unless you stop it explicitly or somebody else stops it. So when a started service starts, it'll just keep running. The download thread service is an example of that. It just keeps running. The intent service, as I just explained, will stop itself when there's no other work to do. So you don't have to stop it because it stops itself when there's no more intents to process. But otherwise, you have to stop a service, a started service, somehow. Either you or someone else, some administrative application, has to stop it. Otherwise, it'll never stop. And the videos explain that and make that very clear. So go back and watch them. Bound services are different. With bound services, a bound service only remains running as long as there is a client, an activity typically, but it doesn't have to be an activity, that has a binding to the service. So if somebody is bound to a service, then until they unbind from that service, the bound service will remain running. And so there's basically a reference count scheme going on here. So when the last client unbinds, then in that particular case, we go ahead and stop. Or rather, the service stops itself. If you watch the videos on bound services, it explains that, again, in great detail, and all the applications show that as well. There's also a discussion in one of the videos that talks about how you can actually have hybrid services, where you can have a service that's both a bound and a started service. There are a handful of examples in Android that do this, one of which is the media player service, which is both a bound and a started service. It's a little bit unusual to do that, but it's certainly doable, and the video explains the conditions under which you would do that. And that's why they have these somewhat obscure hook methods like on unbind and on rebind in order to be able to have services that are both bound and started. I would now like to do a couple things in the remaining time. The first thing I want to do is go and make sure that we've answered all the questions that appeared in the Virtual Office Hours website, because not everybody can always join us. So let's bring up a web browser, make sure that that's working, and let's go take a look at the questions. I think actually a couple questions might actually be for Jules. So since he's here, we can get him to answer some of them. All right, so one question was about this example, which we're actually going to look at here as the last thing today. This is the expand acronym sync versus expand acronym async functions or services, really. So if you take a look at the acronym application, which we'll look at shortly, you'll see that they have two different ways of getting information from a service. One of them uses a synchronous two-way AIDL method call to get the acronym, and the other way uses a pair of AIDL interfaces, each of which have one-way methods, and it runs asynchronously. And we'll look at this in a bit more detail. So the question that David asks is, what's the kind of pros and cons of each approach? And I'll talk more about that when we look at the code. But in a nutshell, the synchronous version requires you to spawn a thread on the client side so you don't block the UI thread, whereas the asynchronous version doesn't require you to spawn a thread. In fact, all the threading is done asynchronously by the underlying Android AIDL and binder framework. So arguably the code is somewhat easier to write for the asynchronous version. There's obviously a little bit more information passed for the asynchronous version because we have to pass the object reference to the callback results object to the server, and then we have to invoke the method to get the results back. So it's a little bit more data passed back and forth, but there's a lot more flexibility. When we go over the code, I'll talk more about this. I'm actually a big fan of asynchronous communication in Android. It solves a lot of otherwise thorny problems. There's also a great example which we'll look at here shortly. Peter Coves came up with a really cool reflection-based solution for being able to create a generic service connection factory, and we'll look at how that works when we look at the code in a second. There was a nice discussion of that. There was discussion about put extra versus set data. Why would you use one versus the other? And I talked about that earlier. If you take a look at the Stack Overflow question or discussion, they talk about the trade-offs. Basically, the reason to use set data is that you can filter on it. And then there's a download file pattern that Ahmad had asked, and it's really not a pattern. It's just a way of downloading files. It's just an algorithm for doing that. Nothing too profound there. There's a question here about the week 7 evaluation rubric, and so I think Jules is going to update that, so that'll be part of the description for when you do the grading. And then there was also a question here about permission and private storage, and I think I will let Jules answer that one. He might just type up a response or something like that. Let me see. Actually, why don't you answer that one? Here are the questions.
So the question is, so by default, so the question is does the protection means that only the user with the same permissions as the app can get access to this directory? and this protection is far from sufficient by default. So by default, if you store data into your private directory and you don't do anything, it will be stored and owned by the user account associated with the app. And by default, that means that other apps won't be able to get access to it. However, if you go and you accidentally change the mode that you're storing it, it is possible to store data in your private data directory and have it world readable. Although this is being removed from Android because developers were unfortunately making mistakes and causing data to be leaked. And I think this was actually even the case with the Skype app, was opening a database but making it world readable and then saving private data in it. Then the question is, can I store files with a good permission in the SD card to keep it safe? In the SD card, it's changing. So in the most recent versions of Android in 4.4, the answer is yes. They are adding facilities so that you can store data on the SD card securely. On earlier versions of Android, that's not the case, to where you can have data stored to the SD card and know that it's going to be only accessible to specific users. So previously, the SD card was just anything you stored there was potentially readable by anyone else. And then the last question was, what really matters, what permissions you store with the files, but actually not the location. So in newer versions of Android, 4.4 and above, what permissions you store with obviously is the key thing. On older versions of Android, it was possible, by default, if you're going to store something in the SD card, anybody else could read it. And if you were storing stuff in private data, it really depended on what permissions you used with it. So yes, the permissions are absolutely critical to store with the right permissions in private data. On external storage, it's now possible to store things privately, but was not always possible before. So at this point now, and then once everybody's 4.4 and above, permissions is what's going to be the really important driver in whether or not you store something so that it's associated and owned by your user account, or whether or not you store it in a way that's world readable, or although that's being taken away too. So in future versions of Android, it's more than likely that it's going to be much, much harder for apps to expose their data to each other on the file system. So Google's really going to a lot of trouble to take away places where developers tend to make a lot of mistakes in their apps, and one of those is writing data to the file system that actually can be read by other apps. So they're taking a lot of those capabilities away to make it so that developers can't mess that up. And instead, what will probably happen is a lot more of the interactions between apps will take place through things like intents, or through services, or through broadcast receivers or content providers and that type of thing, rather than allowing directly reading and writing file system data. All right, thanks.
Great. Okay, so I think that is all the questions that we have up here. There's a question, when will the I Remember app for the second course become available? It already is. That's week 7, assignment number 6. Okay, so what I'd like to do now at this point is switch over and show you a little walkthrough of the Acronym application. Let's go ahead and bring up that window. All right, so let's go take a look at Acronym. Here it is. Okay, so the Acronym application is an example of using a bound service, actually 2 bound services, to be able to interact with a web service. In this particular case, the web service is one where you give it an acronym and it gives you back a list of expansions or potential expansions of that acronym. The service itself is a little bit heavy on medical terms and a little bit light on computer terms. I looked up TCP, for example, and it didn't give me back what I was expecting. I looked up POSIX, didn't give me back what I was expecting. I was able to look up Corba, and it actually knew what Corba was, which I thought was kind of funny. But so let's talk a bit about how this works. The best way to understand services that are defined in AIDL is to look at the AIDL interfaces. So we have 3 interfaces. One interface we see here is called acronym call, and it's basically a two-way call. And you can see here that it's going to defines a method called expand acronym, which takes the string, which is the acronym, and it returns a list of acronym data. So let's go ahead and take a look at the acronym data. First, notice that expand acronym is a two-way call, so it blocks until the call is done. Here is acronym data. Acronym data is a Java type. There's also acronym data, which is an AIDL interface file, and that just defines acronym data as a parcelable object, which means it can be it has to be implemented as we showed on here. So here's acronym data. It implements the parsable interface, and it defines the various fields. It defines the long form of the acronym, in other words, the expanded form, the frequency, how often it occurs, and when it was first added to the database. So those are the three main fields in an acronym. And then we have a constructor that takes a JSON object and converts the JSON into the fields in the acronym data. We also have something that takes a parcel, which does something very similar. And then we have some other helper methods down here that create an acronym data from parcel data. So this is sort of the kind of stuff you have to write if you define objects you want to be able to pass around. So that's basically the version of this thing. Then here's the one-way versions of this thing. We have something that's called acronym request. As you can see, acronym request takes a one-way method or defines a one-way method called expand acronym that takes the acronym, and it also takes an acronym's result object reference, and it's a one-way method. Here's acronym results. Acronym results also has a one-way method called send results, and this is used to send the list of acronym data back to the activity. So you can see here there's two ways to go. One way is to use acronym call. In case the caller will block, the activity will block until the service is done. In the other case, we have a pair of AIDL requests, one of which sends an acronym, sends the acronym request to the service along with a callback object called acronym results, and then the service invokes the send results method to send it back. So it's a pair of one-way calls. Okay, here's the acronym activity. This has a couple of interesting things in it. First of all, notice it inherits from acronym activity base, which basically has all the stuff in here that relates to user interface related code, including how you give it the list view that we're going to use to display the results, and something called an acronym data array adapter, which is what we use to display the results that are a list of acronym data, where you give the acronym that you want, etc. Here's the display results method. As you can see, it takes a list of acronym data and it uses the acronym data array adapter in order to display this thing. All right, so that's the GUI part. That's not really all that interesting for this discussion. Here is the stuff that's much more interesting. So first of all, you'll notice that we have the implementation in the activity of the callback object that is going to be used by the service to send back the list of acronyms after the service is done processing the request. So this is an asynchronous callback. And this callback will run in a separate thread of control from the user interface thread, and this thread of control comes out of the binder framework. And you can see here what it does when it's invoked is it goes ahead and it takes the list of acronyms and it creates a runnable, and it puts that runnable on the user interface thread to display the results. So that's kind of how we get the results back in the asynchronous model. Now we have this super duper cool little framework called generic service connection, and I wrote this, and then Peter Coves came along and fleshed it out and added even more cool stuff with Java reflection. And you can see here what we do is we basically create two objects that allow us to be able to establish connections with the services, either the asynchronous service or the synchronous service, and then be able to get the results back. And this is all pushed down into this helper class, and we'll look at that in a second. So once we got that all set, here's the expand acronym async method. This gets called back when someone clicks the lookup async button. And as you can see here, it goes ahead and uses service connection async object to get the interface to the service. If that interface is not null, then we go ahead and get the text that the user had requested, and then the acronym that they typed, and then we go ahead and we invoke an asynchronous call. So this asynchronous call will call expand acronym on the acronym request proxy, passing in the acronym results callback and the acronym. And this call does not block, so it returns right away. Here's the expand acronym sync call. As you can see, this is a two-way call, as we'll see in a second. What it does is it goes ahead, because it's a two-way call, we don't want to block the user interface thread, of course. So we make a new thread with a runnable, and that runnable turns around and invokes the expand acronym two-way call, which blocks until the call returns the result. And then it takes the result, which is a list of acronym data, and it goes ahead and it puts it on the user interface thread to go ahead and run that. And I could probably have factored this code out a little bit into a helper method, because if you look here, you can see that this run on UI thread code there is essentially identical. So we could probably factor that out into another helper method if we want to. Here's the onStart. OnStart gets called, of course, when an activity becomes visible, and you can see what it does is it goes ahead and it binds to the async acronym, the acronym service async service, and the acronym service sync service. It binds to those two services, and you can see here it uses the make intent factory method to kind of shield the application from any details of how the intents are made. So those are factory methods. So that's how we do the start, and then when we're stopping, when someone goes ahead and has the activity disappear, then we unbind the service, and that basically is a way that services can shut themselves down if their clients are not actively using them at that time. Okay, so that's the activity, pretty straightforward. Let's go take a look at a few of the helper classes. So here's the generic service connection. It's really a framework. It's a very, very cool little technique that myself and Peter came up with. So the idea here is to be able to abstract away all the logic needed to create a service connection to a generic, it's a generic service connection class, which can be parameterized with generic type for whatever kind of AIDL interface we're trying to deal with. Acronym request, acronym call, etc. And of course, we could factor this out into a library and make it reusable. So it sets up a couple of static final strings and classes to be used with Java reflection. We then reflection objects, something that keeps track of the class, something that keeps track of the method. We have an interface to return the IDL interface that we've got based on what we parameterize this class with. And then here's the real workhorse method. This is the constructor for this thing. It goes ahead and it uses reflection to take whatever we pass to this, which could be the async request class, or I'm sorry, the acronym request class or the acronym call class, and it gets from it the stub method, which is a method that's generated by the AIDL compiler. And it stashes this thing away in the method, it stashes it away in this thing called m_as_interface. And then down here, when the onServiceConnection method is called, now keep in mind that onServiceConnection is going to be called because this class inherits from ServiceConnection. So when something is connected, Android, the Android service framework, automatically calls the onServiceConnected method back. And what that does is it comes in here and it goes ahead and it invokes the stub method on the reflection object, and it gets back the interface that comes from that. So this basically is going to be used to convert the service that we see here, this service, which is an iBinder, into the appropriate AIDL interface, and then that's stashed and used for other stuff. And on service disconnected, we'll simply go ahead and set the interface to null. So this basically factors out this code that you otherwise have to keep rewriting over and over again from scratch, and it's very tedious and boring to do. If you take a look at how to program the bound services that we show for the unique ID generator application, you'll see how you have to do it normally. Let's now go ahead and take a look at the synchronous version of the acronym service. As you can see here, this will go ahead and create this thing called acronym call impl. So we take a look at acronym call impl, and that's actually defined down here. And so the onBind method returns that reference as an iBinder. Here's the make intent method, which just makes the appropriate intent. And then finally, we have the expand acronym method. Now, this expand acronym method is the two-way call. So it inherits from the stub that's automatically generated by the AIDL compiler. And then this method goes ahead and it calls into the acronym downloads util library and calls the get results method, which we'll look at in a second, which gives it back a list of acronym data, which it then goes ahead and returns. So this call will run synchronously in the service out of a thread in the thread pool. So this runs in a pool in the thread pool. So you can see it goes ahead and contacts the service, and then it returns the results. If we take a look at acronym download utils, you'll see that basically this has the acronym URL, which we could have provided as a parameter, but we kind of hard-coded it here. That could probably be fixed and improved. Here's the get results method. You give it a string and list of acronym data, which is an array list, and then it goes ahead and it calls some helper methods to go look up at the acronym URL, the particular acronym that we're looking for, and then what it gets back, of course, is JSON encoded information, and it goes ahead and it puts those things into this list of acronym data, and we'll look at this in a second. Here's the helper method. This thing goes ahead and connects to the web service at this URL, and it gets back an input stream, and then it goes ahead and it reads all the contents from this into a string. And you can see here's what read all does. It just basically reads the contents from the URL that we got with the input stream. It reads it back into a buffered reader, and it puts this into a JSON array, and it returns that. And so you can see if you pop back up here, we go ahead and we get the JSON object, and then we go ahead and we crack the JSON object up, and we take each of the pieces, which, because you could have an acronym, of course, could be expanded into multiple different results, which we call acronym data, and we stick those things into this list of acronym data. So we're kind of converting this. The purpose of acronym downloads utils is to convert from the world of JSON and web services into data that's understood by Android and understood by Java in a more direct way. So that's what acronym download utils does. Then we can take a look and the async version of this service. So the async version also has an onBind method that returns an acronym request implementation, and it has a make intent. It has a slightly different stub, request stub, not the acronym call stub, and it has an expand acronym method that takes the acronym and a callback object. And what it does, of course, is it goes ahead and it uses the same get results method to go contact the web service. And keep in mind, this runs in its own thread of control in the binder framework. So it's running out of a pool of threads. So it doesn't block the server, doesn't block the service, doesn't block the client. And then when it's done, it goes ahead and it does a send results to send the results back to the callback object, which resides on the activity side. Now you'll notice that this particular implementation uses the same thread that received the request to send the result back. That is not necessarily how you have to do things. You can imagine basically making this method call here and then storing the results someplace else, maybe in a queue or a list, and then having a separate thread of control that wakes up and then sends the callbacks back to the client. So there's no need in a asynchronous version of this thing to have the caller, the callee thread, which is the services thread, blocked synchronously. And that has some scalability implications. It's easier to build scalable services using entirely one-way callbacks because you don't have to have as big a pool of threads to handle them. Okay, so that's basically how that works. And then the only other thing that really we haven't looked at is the acronym data array adapter, which is basically an array adapter, and it takes that we can display the results. So when the results get displayed, we put the year first, followed by the number of references, followed by the expanded acronym string. So that's basically how the acronym application works. It's really kind of cool because as you see here, we have a bunch of interesting little things. We have the use of the generic service connection framework to really reduce the amount of programming you have to do, and that's a nice reusable class that could be used for other services, not just this one. We have both bound and unbound, we have both asynchronous and synchronous examples of services, both using AIDL. By using AIDL, as we have done here, we can program at the level of native Java objects, in this case acronym data, and a list of acronym data, rather than have to deal with JSON ourselves. We push all the JSON processing into the service, so the service shields the application from any knowledge of JSON. That's all been abstracted away by the time we get the results back from the service. So it kind of illustrates some of the key benefits of bound services using AIDL, right? We get asynchrony for free. We get concurrency for free. We don't have to program that. There's no threads in our program unless we happen to do the synchronous version where we have to spawn a thread. But if we don't do the synchronous version, threads are handled for us automatically. We see that we can write a reusable service that shields the application from knowledge of how the web service works. We don't have to know about the data types that the web service knows about. We can work with things that are meaningful in our environment. The generated code means we don't have to write that code ourselves at the application level. Of course, we have to write it in the implementation of the acronym data to do the transformation back and forth between the different types. But that can be done one time by an infrastructure developer, and then application developers are not concerned anymore with cracking open and marshalling and demarshalling things. So asynchrony is really easy, concurrency is really easy, dealing with marshalling and demarshalling at the application level is really easy. So it's kind of a really neat example, and it also illustrates two-way communication between activities and services. Okay, let's see. So Dell asked a security question. Dell, why don't you go ahead and post this question to the web forum, to the Virtual Office Hours Week 7 forum. Jet asked the question, what is Java Reflection? Well, if you Google Java Reflection, you'll learn a lot about it. Java Reflection, in a nutshell, allows you to write programs that can discover information about the program itself. So we used Java Reflection to be able to look up the stub method in a class, and we were able to use that to then invoke that method with appropriate parameters without having to explicitly write that code ourselves. So Reflection gives you a way of being able to introspect or reflect on the types in a Java class in order to write code that will automate certain kinds of things. It's a very, very powerful technique. So Ashley asked a question about concatenating empty strings to cast non-strings to strings is bad practice. I'm not quite sure what that question is in reference to. Let's see. All right. So there were a couple questions here about. Oh, here's a great question. So Derek asks, can you bind a service to another service? Yes, absolutely. And that's one of the things I was making as a point before. By using the bound services as we have, you do not limit yourself to activity to service communication. You can actually have services that talk to other services. That all works perfectly fine. Okay, so let's see if there's any more questions. So hopefully everybody got something useful from this discussion. A couple more things before we wrap up. First of all, I'll probably make 2 videos for this week of office hours. I'll make one with me presenting the stuff about week 6 assignment 5 and the acronym stuff, the acronym application. That'll be one video. And then I'll make another video of Jules answering questions and talking about the upcoming assignments. Something else I want to kind of elaborate on. Let me see if I can bring up a web browser to make this point more concrete. Let's see. Go find a browser somewhere. There we go. That looks like a promising browser. Let's bring that one up. Okay, come on. Nope, wrong one. There we go. I think that's the right one. Okay, so hopefully you can see this browser. Let me just double check to make sure. Yep, okay. Let's take a look at the Coursera site. Oh, and I want to go to the next one, the mobile cloud one. So we're getting ready to release what you're about to see here, which is the Coursera session page. And here is the syllabus for this class. Make it a little bigger. And as you can see, as Jules said, we've broken this up into kind of two parts. The first 5 sections will be the quote mandatory part of the course. Those will be the sections that he'll be doing, and there'll be mandatory programming assignments using Java Spring for that part. And I think the goal here is to probably have auto grading for part of it, and then optionally have peer assessment, which is a little different from how we're doing it. We'll have to see how this goes. We're trying to be sensitive to people's needs to not have to spend the entire summer doing MOOCs. So one of the consequences of that is it's a little harder to require peer assessment because you sort of physically have to be available to do the peer assessment, or you don't get your grade. So I think what we're going to probably do is make peer assessment optional, and so people who want to be peer assessed can peer assess each other. And we probably won't score that, but I think a lot of people get a lot of benefit from seeing other people's code and getting comments on their own code. So we'll probably do that, and then we'll make the grading be auto-graded, assuming we can get all that to work. And then there's another part of the course, which we'll do in the other weeks. So there'll be 6 weeks of mandatory part of the course, which can be spread out over the summer, the remainder of the summer. And then there'll be 4 weeks worth of material, which will be optional. And this will basically be patterns and frameworks for concurrent and network server software. So Jules's part will largely assume that there's a web server and a web services infrastructure, and then talk about how you program that. The part that I'll be presenting is a series of optional lectures talking about patterns and frameworks for developing web servers. Now, you probably aren't going to be developing web servers, obviously, in this day and age. But what's interesting about this is whether you're developing web servers or not, if you develop servers that run in server environments or clouds or data centers or whatnot, then the topics that we'll be discussing in this section will be very, very relevant. So as you can see here, there's lots and lots and lots of patterns. We'll be talking about basically most of the patterns in the POSA 2 book, and we'll be giving examples of these patterns in the context of building web servers. And there's open source implementation that underlies all this stuff, and we'll show examples of how to program all the different patterns and so on. And these examples, unlike the examples for Jules' part, which will be using Java and Spring, this part will be using C++ and ACE. So again, it's optional. If you're interested in this, you can follow it all. If you're only interested in the patterns, you can watch that stuff and ignore the C++ part if you don't want that. If you don't care anything about this, you don't have to watch any of it. It's just there for optional purposes. And that'll take basically 4 weeks. The other thing I wanted to show you is what I'll be doing for the couple weeks between now and when Jules's class starts. So as you probably know, this is sort of officially the last week of new material in the course. And then what's going to come after this for the next couple weeks, again, is entirely optional. You're welcome to watch it or not. These will be videos going over patterns largely from the POSA 2 book, also from a couple other books, like the POSA book or the Gang of 4 book. We'll be talking about patterns applied to Android. And so next week, as you'll see, we're going to have the activator pattern, the command processor pattern, the proxy pattern, and the broker pattern. So these are kind of communication patterns, and we may put the publisher subscriber pattern in as well. And then, so that'll be this coming week. And then the week after that, there'll be a bunch of optional lectures that'll cover various concurrency patterns, thread-specific storage, active object, half sync, half async, and so on. And so by the time Jules's class starts, for those of you who are interested, you can watch patterns about how things are used in Android. And these videos are done a little bit differently than the ones that we did before, because they're actually filmed from a class I taught last year, and so I'm not making them. They're not required videos. Not that any of the videos are required really, but they're not. They're explicitly labeled as optional. But you might find them useful, and if you need some more information about patterns, there's lots and lots and lots and lots of stuff there. Yes. So if you want to follow along to the web server portion in the next course, you'll need to, if you want to follow along with the examples showing frameworks, then you'll need to know how to read C++. Although honestly, if you know Java, what we're doing in C++ isn't all that much more complicated, just a little bit different. Okay, well, I think we really are at the end at this point, so I'll see if there's any more questions. Otherwise, thanks a lot for attending. As I mentioned before, we'll put up the videos here, probably have 2 of them, and that'll probably take a few hours because these videos tend to be rather massive, and it takes a while to edit them and to be able to upload them and get them up on the website in the right format that people can look at. I'll probably put them up on YouTube first, and then once they're processed on YouTube, I will upload them also to the Coursera website as well. And with that, thanks very much for joining us, and we will look forward to talking to you again either on the forums or in next week's virtual office hours.